Hi guys, welcome back to the channel. Today I have an amazing concept in ANSYS, that is using the commands of APDL. And in today's simulation I'm going to illustrate how you can use ekill and ealive commands such that this simulation, during the first during the first step of the simulation, the the top plate, this one is a top plate. For the if you go to geometry here, this top plate doesn't move, but the bottom plate moves. Then during the second step, because you have two steps analysis, the bottom plate moves. Let's make some small simulation. This is a total deformation. Just let me animate. You can see during the first step the bottom one moves. Then during the second step, the top moves. It is because during the first step, we want to ignore the spring. I'm using a spring. This is a spring here, you can see. Longitudinal spring that connects these two plates. But for this to work, I have to use two steps. Number of steps, there are two. During the first step, um, I'm not using the spring. It is dead, in other words. But during the second step, the spring is alive. Therefore, it is called a dead and alive element method. Let me illustrate how to perform this analysis. As usual, go to the workbench and select static structural. You can rename your project. Maybe you want to call spring plates. Then I need to model a simple geometry using the space claim. Space claim took some time to load. This is the space claim environment where we can model our two geometries. I need a rectangle on the ZX plane, therefore rectangle on this plane. I need maybe 40 by 60. 40 by 60, that's fine. Then I need a circle here, maybe of 10, like that. On to pool, we select pool, this pool by 10. Then yeah, that's the bottom plate. You can rename as bottom plate. I need another plate that is 30 mm away from this surface, therefore you can have a plane onto this face. Then I want to move the plane, move this plane up by 15. Then I want to use mirror this, my plane and my body, like that. That's fine. You can delete this. That's fine. You have the bottom plate and top plate. You can now close the space claim and select model and edit to start the mechanical environment. This is the workbench for the mechanical side. You can see now the geometry imports from the space claim. We have bottom plate and top. Let me rename this here. Rename is top plate. Let's rename even the top one as the bottom one as a bottom plate. Okay. For the material, I'm going to use the structural scale. These are the properties. The tensile of strength of 460, 250. Okay. For the connections, I want to connect these two, the bottom plate to the top plate using a spring. Therefore, right click, insert a spring. The type of spring I need is a longitudinal spring. For the stiffness, I want to use 10,000 newtons per millimeter for the stiffness. I want this spring to be very stiff. Then for the scope, the reference one, I want to use the top as my first point. Attach it to there. I want to attach to the bottom face, this face here. That is the mobile. This is the mobile one. I want to attach this point. Now the spring is attached. It is attached in both plates, the top and bottom. That's the connection. Then I need to define the fixed surface. I want to insert fixed support, this support and this support, like that. Then I need to insert a displacement on this face. I want this face to move on negative y-axis by 20 millimeters. Therefore, on y component here, this is the face I want to move. On the y component, I will use 20 mm. But for now, I first need to define the number of steps. I need 2 steps here. Let me go back here. Then for the y component, I want to use tabular. Then on the first step, to have a negative 10. Second step to be negative 20. You can see now it will start from 0, go to negative 10 on the first step, then on the second step go to negative 20. That is the reason why I'm using 2 steps. And I want to define large diffraction to be on, because this one will deflect a lot. Then I want to use the other as default, but let me first select the worksheet. I need now, these are the parameters I'm using, but for the auto stepping here, I want to use on and use sub steps. I want to use 10 sub steps, 10 here. That is on the step 1. Same thing on step 2. The same thing happens. I want to use the initial sub steps to be 10. I want to go into deeper details on the settings. If you want me to explain in a deeper details, I will make another video. Just comment below this video. For the auto time stepping, let me use on defined by. I can use time and sub steps. Let me use the sub steps and also use 10. I'm using 10. Carry over time step. This one will leave them as by default. Here they are. Leave them as default. That's the analysis setting. I have done the fixed support and remote displacement. If I was to solve this now, let's see what happens if I solve. Almost done. 97%. Let me now insert the deformation, total deformation, and get this result. You can see if you animate, both plates move at the same time. You can see they are moving because now this spring is stretching. But now I want to kill this spring such that during the first time step, the first second, you have 0 to 1. That's the first sub step, or the first step. The spring doesn't function, but during the second it functions. I have to go back here. You have to insert what we call a command. The first command, I want to tell my software, I want to assign this spring as element. You can see here the material type and real number of this spring is equal to the spring underscore SID. Therefore, I will give the spring an ID of the spring equals, you have to assign this parameter SID. This is the element that SID. This means that the software will now remember this spring in the ID, that is SID parameter in the spring. Therefore, if I now go here, I can insert command, and I want now to rename this one. I want to kill ekill. I want to kill the spring in the first sub step, and I want to use in the first step selection mode first here. You can use first or last, but I want to use first. Then I want to select that is, we say the command is cell select S type. Remember it was an S type here. If you go back to this, to the you're using a is equal to SID. Therefore, you have to say S type because there's an SID. S type the spring, like that. What it does, it selects element, cell for select element of S type, the spring. Then it kills the element, ekill all the elements selected and above. After killing the element, then it selects everything, all cell, everything. Okay, this happens in the first sub-step. Let me insert another command for now, ealive underscore ealive. The same process, eCell, S type, what? The spring. Then we need now to ealive the element, all of them. Then you select all, like that. The first one was to kill the command, but now this second one, it happens in the by number, and select by number in step number 2, or we can select last. Here can use by number or can use last, because here using the first sub step and last. Let me use by number and use second one because you have 2 steps. Something very important is The element you want to kill, you have to give it an ID. Here, that is S. The spring is the ID of the element. If you are doing a simulation that maybe certain element gets born during the analysis, you can kill that element. As the simulation progresses, you then bring the element back to simulation by using ealive command. These commands are very used when doing the welding analysis. If you want to do the simulation of welding, whereby you kill elements, then you bring them back to life. Let's now run this and see the differences. You can now solve. It is solving. It is taking some time to solve because this one is an nonlinear analysis. It is not linear. Yeah, it is almost done. Let's see now what happens to the total deformation. How now to run. You can see now during the first sub-step, this one doesn't move. You can see that it moves during the second sub-step. Okay, then we can now, the same thing, I can also insert von Mises. Let me retrieve this result. This one is high stress than this because this one moves all the time. You can see now the stress build here is small. Yeah. Then also we can now get the probe. Let's get the spring. First of all, let's get the reaction force here. Insert. I need to get a probe and I need to get force reaction at the fixed support. Yeah. Another one, probe. I want to get the force reaction at remote displacements. Retrieve all results. Okay. You can see now the force along Y. It is, let me deactivate the others one are negligible. You can see, therefore, this is one is the reaction force on the remote displacement 9530, 9540, almost the same thing, because the reaction force here has to be equal to the reaction force here. The reaction force at fixed support has to be equal to the reaction force at the remote displacement. You can see here we have 9541 at the fixed, 9530 at the displacement. Lastly, we can get a probe for the spring. Let's see how the spring behaves. I want to see the force of the spring along. I want to see you can see the elongation here. During the 0.1 to 1 second, the spring doesn't elongate because it is using the ekill command. But from 1 to 2 seconds, the spring elongates. You can see from this point, you can see the force here. Let me deactivate this. This is the spring velocity. I want to use this too. You can see here, during the first sub-step, the spring doesn't have any force, but from the second sub-step, the spring is alive. Hence, it have some force. That is 47,451. If you do the math of the Hooke's law, you're going to get this value using this elongation. Remember we use the spring value we used here on the connections. We use the stiffness of 10,000. Okay, that's how you use the commands to activate and deactivate a certain element. Thank you. Stay tuned for more advanced concepts in ANSYS.